I'm your host, Grayson Brulte. Welcome to another episode of SAE Tomorrow Today, a show about emerging technology and trends in mobility with leaders and innovators who make it all happen. On today's episode, we're absolutely honored to be joined by Behnam Hormozi, CEO and founder, Integrals Power. On today's episode, we'll discuss how their new cathode technology is driving affordable, high-performance batteries for longer-range electric vehicles. We hope you enjoy this episode. Behnam, welcome to the podcast.
Thanks very much. I really appreciate the invite.
It's great to have you here. The UK is a wonderful country. You are the United Kingdom. You have really great scientists in that country that are building game-changing, world-changing technologies. And you're focused on material science breakthroughs with the LFP and LMFP chemistries. How are they improving electrochemical performance at the cell level?
Yeah, so obviously, as I'm sure you know, LFP and LMFP are playing a key role in terms of the future of EV propulsion systems. And so we have been focusing on that sector for a good 5 years now. And one of the main reasons into that is actually, especially for LMFP, allows you for improvements on the energy density level, and not only at the cell level, but also at the system level, really. So not only allows you to be able to increase the range of an EV, for example, by up to 20% more, but also allows you to be able to adopt a less, I would say, complicated designs around the cooling systems as opposed to NMC chemistries, which is another reason to why it will have a synergistic impact to be able to have better performance metrics beyond the cell level. And so even at the system level, by adopting these chemistries, it allows you to have more condensed and a lighter and even more compact design, which ultimately it is for the advantage of the end users at the vehicle level.
In the US, there's a debate that rages around range anxiety. Well, can't buy that. I can only go, say, 210 miles, 220 miles. In the UK, is that debate still there like it is here in the United States around range anxiety?
I think the public awareness has been massively improved compared to a few years ago. And so although the range anxiety does in a minor shape and form still exist, I guess, being absolutely frank myself, if I was to, talk about EVs, I would ideally like to not be worried about where the next substation or a sort of a charging point is and having to sort of divert my route into that direction. And so I guess realistically, it does still exist in a very, very sort of a smaller proportion as to what it used to look like a few years ago. But then something that's become more and more clear is that thanks to the synergistic impacts of the other, I would say, components within the EV system, i.e. the type of anode materials that are currently being used, as well as cell-to-pack designs, it has really allowed for more synergistic improvements, even at the range level, where if you were to use the conventional chemistries, such as LFP cathode, you're no longer just talking about a 200-mile range. It's now gone beyond that certain threshold, even beyond 300 miles, and really, which is pretty much, I would say, in the range of an identical point to a sort of an ICE car. And so I think, given that the technologies have developed in other components, it has played a massive role into it. And so we're expecting for the concerns around this range anxiety to very soon be negligible over the sort of the next 1 or 2 years, not only in the UK, but also globally speaking.
Is chemistry still so you get a smaller pack size, higher density? Is it the chemistry is where you're seeing a lot of the investment going is to perfect that?
Absolutely. So the chemistries on itself, especially the cathode on itself, it accounts for roughly about 30% of the weight of an overall weight of the battery packs, if you like. And so understandably, even at the cell level, nearly 50% of the cost is driven by the cathode that's been also adopted, which justifies the reasons why a lot of investment and improvements are required for that, because that's where you can get the best out of your investment in terms of its return. But more importantly, it allows you to be able to have a more meaningful impact in the overall performance metrics. And so that's been predominantly the reason why chemistries such as lithium iron phosphate have been more commonly used compared to conventional chemistries such as NMC, where they're no longer being seen as a more of a competitive approach as opposed to LFP. And now the next generation of the chemistries, which is what the Integrals Power has developed, such as lithium manganese iron phosphate.
When your chemistry, one of your big breakthroughs, I've noticed that you use more manganese than traditionally has been used. Why is that? Why do you think other, let's call them competitors or other individuals in the industry, have not experimented necessarily with that?
So I would say dealing with manganese, it is very challenging. So manganese on itself is a it's a very non-conductive material. And so I always say this, probably adding manganese is the last thing you want to really do to your cathode. But again, it does come with this upside, which means it allows you to increase the voltage levels, and specifically the average operational voltage beyond the existing LFP. So LFPs are strictly known for about 3.2, 3.3 volts. By adding manganese, you're increasing that threshold up to an average of 3.7, 3.8 volts, depending on the composition amount of manganese you have added. And so understandably, the more manganese you can add to the existing LFP, the average operational voltage can also be relatively increased. Because of the nature of manganese on itself, which, as I mentioned, is non-conductive, it does require a different sort of parameters to be worked on, and also mostly controlled during its synthesis process. This means it phases out most of the existing conventional approaches that are currently being used for development of LFP, i.e. solid-state synthesis approaches. And so it does require an awful lot more investment in terms of the resources, the capital, but also the new skill sets that need to be acquired, even in China, to be able to demonstrate LMFP's development at a higher grade of manganese. And so we have seen a lot of movements very recently around LMFP development for manganese that are accounting for about 60 or 50, 60, or even 70% composition of manganese. However, 80%, we believe Integrals Power is one of the only companies that has so far been able to achieve that. And that ultimately stems from our unique approach towards the development and the synthesis of the materials, which is quite unique compared to the conventional players in the market.
And what's the impacts of the VW has been very public, and they put out scientific papers of going towards 800 volt. What impact does that have as we go towards higher voltage for charging?
So one thing you need to bear in mind is the average operational voltage of LMFP is very comparable to NMC. And so one of the, I would say, the most important advantages of LMFP is that it is a drop-in replacement, right? And so from the cathode perspective, if you know how to deal with LFP at a cathode level, you'll be very comfortably able to do so with LMFP as well. This has been proven with regards to the other 6 organizations who have so far tested our materials at the cell level successfully without any challenges. And so with that regard, there are not major challenges when it comes down to electrode making, cell making processes, which validates why LMFP can be seen as a drop-in replacement. But now moving on to the operational voltage, where battery management system and pack is more integrated and more involved. Given that the operational voltage of LMFP is similar to NMC, again, from a pack level design or a battery management system level, it is a matter of replacing the NMC's operational voltage, which is about 3.7 volts by LMFP again. So we are really providing a sort of a next generation chemistry that can be seen as a drop-in replacement, which doesn't require an awful lot of investments in any level. That includes at the cell level as well as a pack level.
But on the backside of that, how are you sourcing the materials? Because China, for all practical purposes, 90% of the supply chain, so there's risk there, and not just you, but the whole industry has that risk. And we're seeing different regulations in Indonesia because of the nickel runoff. How are you managing for those risks as you develop, I'll call this breakthrough chemistry?
That's a very good question. I think this is really a short-term solution and a long-term solution that needs to be addressed. So in terms of the short-term solution, obviously where we are today is at a 20-ton per annum pilot line facility scale in the UK, Milton Keynes. And so we are currently comfortably able to outsource our materials domestically. And by domestically, I'm mostly reflecting on UK as well as Europe, where we have been successfully able to outsource these materials. However, going forward, we appreciate that there will be challenges around the scalability of the supply chain. Although we have really gone through that validation of our suppliers through our previous scale-up plans that we had. And so when we pivoted from lab scale to pilot line facility, we have already gone through a transition of now outsourcing materials from large-scale suppliers. But one thing that we have been seeing confidentially on the basis of the companies who have approached Integrals Power, it is becoming quite clear that the investments within the supply chain for the raw materials are now being expedited and increased, understandably, because it is not an option of having a domestic supply chain. It's really a matter of a time because of the regulations and tariffs, as well as rules of origin, that is playing a massive role into this. And so there are going to be many, many more players as opposed to what you're currently seeing in this landscape because of discussions that we are having. And some of those companies are currently in partnerships with Integrous Power with regards to the assessment of some of those raw materials so that they could be fully scaled up for the products. And so I think given that Europe and the UK are not yet at the verge of being able to be seen as one of the largest suppliers of such materials, although from many aspects it's not a good thing, but the upside to that is it gives us a bit of a head start to make sure that the supply chain can also be secured. And so by the time the companies like Integrous Power are able to supply such materials at a larger scale, they would also have the same proportion of that supply chain into the raw materials within the ecosystem of the UK and Europe to make sure everything it's aligned to what the needs are within those regions.
If you look at the publicly stated goals of the government and the prime minister, and if you look at the mayor of London, you look at their very publicly stated goals around the transition to electrification. When does the battery supply chain in Europe become a national security issue for the UK, where you start to see the full power of the UK government look to secure the supply chain for EV batteries, and also invest perhaps in the Cornwall region where you can start to create all these jobs and at the same time securing your national supply chain?
It's a bit of a chicken and egg situation, really, because it really, I guess I need to refer this to the changes that are being made towards the legislations. I guess if the infrastructure is not ready to be yet embedded into the full landscape of your expectations, even from a government level, then the fact that you are making more strict sort of changes around the supply chain will not be necessarily aligned to those legislations. And so it's not just a matter of a legislation that needs to be in place, but it needs to be up onto a level where it is fully effective and executable. And to do that, you need to make sure the expectations are meeting the potential opportunities also within that region and the country. And so, for instance, the rules of origin, that's also something that I have also been able to contribute towards. It's the changes around the cell manufacturing, where the suppliers of cathode material, especially for LFP and soon to be LMFP, need to be within the UK or the European ecosystem, or otherwise the OEMs would have to actually pay at least a 10% penalty to be able to benefit from, I guess, a non-European supply when it comes down to the cathodes. But then that still gives them a bit of an opportunity to be able to outsource the byproducts from outside of Europe. And so I guess the expectations are for that rules of origin and those legislation to be fully practiced and executed. It obviously would require other infrastructures to be within that system already, so that everyone can actually opt into that and be able to commit to the expectations from the government level. And so I think it is becoming gradually a matter of that national security when it comes down to the domestic supply chain. The upside to that is government has acknowledged that we do require some decent amount of time to be able to have that transition. And so it's not an overnight action. It is something that's going to take a few years. And so although China has been massively becoming a dominant player in this landscape, the chances are that for China to retain a huge amount of that market, even within the next 5 to 10 years. But the best that we can do in the UK and Europe is to be able to reduce some of that amount and be able to reassign some of that market share to Europe and the UK by being able to play a part into that. Because at least the upside to that is that you will not be massively taking a hit on to the changes that could be specifically on a basis of price points. I mean, for example, something that has come up very recently in early 2025 is that the Chinese government has proposed to ban the export of technologies for LFP and LMFP. And understandably, I think it is become very, very clear that LFP and LMFP are going to have a key impact on the EV transition, because as per the statistics, just last year on itself, roughly about over 40% of sold electric vehicles globally were powered by this chemistry. And so it is going to become more of a concern going forward if we want to really focus on net zero goals and be able to have the EV transition goals being met.
You have to, at the end of the day, China has a lot of advantages, but from geographic wise, because the shipping lanes from Australia, a lot of the raw materials are coming out of Australia, going into the Chinese refineries, but it is also an old UK penal colony. So perhaps you can use some of the old policies in place there to bring some of that materials back to the UK. When you talk about infrastructure, is it metal refineries? Is it battery plants? What type of infrastructure ultimately needs to be built so the UK can build a self-sustaining battery industry?
So at the moment, there are a few challenges, or maybe I shall say opportunities around enabling that transition, really. And so in addition to the opportunities for supply chain around battery materials, or basically active materials, the raw materials aspects also needs to be taken care of. I know we very lightly touched on the lithium refineries that are being currently worked on a scale up, but I think it does take a bit more than that. I appreciate why lithium has been the main center of the focus, because it is going to have a massive impact in terms of the price point as well as the security of the supply chain. But there's still an awful lot of other stuff that needs to be worked on in terms of the phosphate refining on itself, the manganese, as well as other materials, which at least are going to have a massive role into the materials production for LFP and LMFP. But then moving on to the next step, as I said, with regards to active materials point, we do not have many companies in the UK that are focusing on cathode productions. Specifically, in terms of LFP and LMFP, Integrous Power is the only company that is currently working on the development and the scale up of this technology at the scale that we are at the moment. And so, although that is promising in terms of being able to be positioned at the forefront of that technology development, it would be great to be able to contribute, I guess, with more power and having more companies being able to work towards that sector. It doesn't necessarily have to be this specific chemistry, but it is something that, as a technical, looking at it from a technical perspective, cathode material, it is quite vital to have in order to have an operational battery. And so those are different areas that need to be worked on to make sure that transition is going to happen. But moving on to the next point around that chain and the value chain and supply chain, I guess cell manufacturing, it is something that we've seen, unfortunately, some of the companies that have failed to achieve the large scale facilities in the UK. Obviously, British World was one of them, but I am hoping that's an area that could be further improved, because having a domestic supply chain, for instance, a cathode that could be produced in the UK, it might not add tremendous amount of value unless you are able to exploit and demonstrate that at the cell level, also within the UK, within that ecosystem, or else these materials that will be produced will need to be shipped out to Europe or North America, for instance, for exploitation and the commercial demonstration. And so I think those are the areas in terms of infrastructure that needs to be invested on. We appreciate that it is a time-consuming process, and they are very, very capital intensive as well, of course. But this is where the government, especially the UK government, can play a huge role. We have seen such commitments from North American government where they have been really playing a massive role in enabling that transition by being able to invest more directly, whether that's through public grants or other sort of mechanisms that could be tapped into to be able to benefit from that. But something that we have seen is that we cannot rely on just the private funding to take the full-on risk, especially at such early stages for startups that are working on the scale-up of the technology. Given the climate that we are at the moment, from sort of a financial climate point of view, I think it has become more important than ever that the UK government can also support that transition and be more hands-on and involved to make sure the supply chain can be really secured in its full extent, starting from the raw materials, active materials, all the way to cell manufacturing, as well as pack manufacturing.
In the United States, we've seen a lot of success historically with the public-private partnerships, which have started, for all practical purposes, they'll get a lot of pushback on it, but Tesla was, for all practical purposes, a public-private partnership with all the subsidies that they got when they started. And it's turned into a huge success. In the UK, you have a very proud automotive business. So you have JLR. I know it's not owned by the UK anymore, but it's still there. And then you have a fast-growing UK auto company now, Grenadier. I'm surprised at how fast that company is growing, especially with the exports to the United States. Then you have everybody's dream car, Rolls-Royce. How is in all of those companies, Grenadier's publicly stated it, JLR stated it, Rolls-Royce has stated it, amongst other UK car companies, that they're all going towards electric or to hybrids. How are they thinking about all this battery manufacturing in the UK? Are they championing it? Are they offering to potentially invest in it, or to, I'll use the American term, lobby the government to say, hey, we need some subsidies? How's the UK auto business thinking about this?
I think it's a bit of both, really. I mean, it's talking about the existing dilemma that we have in here. I mean, there is a lot of discussions around where the UK government's expectations are. For example, the OEMs that would expect further subsidies. I guess we have very much good benchmark in this case, talking about United States, where they are really doing a cracking job in terms of their investments and being able to support by subsidies, by offering further grants to secure that. Unfortunately, that's something that's been lacking. I think, I've said this times and in different occasions, where the UK government has done a great job in funding very, very early stage developments at the lower TRLs of 1, 2, 3, where it is successfully able to prove the concept, which is great. I think UK is doing that job very, very greatly. However, as soon as it starts to build into a very, I would say, demonstrable stage where there is a bit of attraction that could be attained and shown, that's where we are then focusing on a larger amount of investments that needs to be made. And unfortunately, there's a huge gap and a bridge between where, for example, United States is compared to the UK, for example. And so in order to be able to bridge that gap, this applies to all of the players within this sort of an EV landscape. I mean, we've been mostly talking about the battery sector, but talking about the EV manufacturers and shifting now to that electric vehicle propulsion, it is becoming a bit challenging. I think this is something that I have been also hearing in terms of expectations for the subsidies and making sure the government can provide further supports to make that happen. It's I guess something that needs to be clarified is that maybe the UK government is not yet able to fully commit to that. I'm not sure if this is on the basis of the sort of discussions that still need to be had, or the consultations that still need to be conducted to have a better understanding of the existing infrastructures that we do have in the UK. For instance, we did realise that obviously Stellantis pulled out of the manufacturing site they had in Luton, which is not actually very far from where we are. It's just about 20 minutes drive. And so we have seen that happening time and time, and where other EV OEMs have decided to pivot from UK to North America or elsewhere. And so I think UK government has appreciated and acknowledged that very well. And so it's very interesting we're having this discussion today, because I think today also we have been expecting to hear from the UK government in terms of the new spending review and the budget. And so I think I have already heard in a very quick snapshot of there are going to be further investments made within this landscape, because they also appreciate that. But it's hopefully a matter of time until we can have a more investable infrastructure ready in the UK for other OEMs.
And I want to highlight, and this is all in the public record, that the UK has championed technology for decades, hundreds of years. One of the most recent, very public examples is ARM, based in Cambridge. When SoftBank acquired ARM, the government, it was all these mandates about the job creation, the jobs in the headquarters had to stay in Cambridge. And Masa-san has honored that and tripled the amount of investment he agreed to make in Cambridge. And if you look at, let's say, 95% of all EVs have some ARM architecture in them. So you have the chip technology there. And if you're going to build the battery technology, there seems to be, okay, that could start as, if you want to call it an accelerant to a really, let's say, a growing, thriving industry.
Yeah, I mean, we are experiencing the very same mindset, which is not very helpful in many ways as well, because it does create that expectation also from the sort of private sector investment point of view, where it is shifting majority of the startups towards this concept of having a more of I would say a hybrid business model that will be driven by licensing or joint venture opportunities, rather than being able to see companies that can become a large player in terms of the manufacturing capabilities. Understandably so, because it would require a lot more capital to be invested in. But it does mean that it takes away I wouldn't say motivation, but the feasibility of seeing these startup and technologies to be fully exploited up into its fullest potentials within the country. And so that is the potential downside into it. And so I think the UK has been doing a cracking job in terms of being able to develop technologies in many, many different sectors. That's absolutely correct. Even in the battery landscape, we have seen that happening quite a lot. But whether UK is also very well known to be able to fully transition and be able to exploit that technology within the same country, which is the UK. I don't think that we've done a great job so far. And so I'm hoping that can change, because if a local supply chain does matter, this is something that we need to be willing to make it better.
Everybody wants a supply chain to be local, any industry. I mean, if you look at the most common one globally, everybody wants the food supply chain to be local. So why not have a technology that enables you to go to the store to buy your groceries, to have that be local? All supply chains at the end of the day will become local. So you're investing in the business. You're committed to the UK. Is the goal to ramp up manufacturing in the UK, or is the goal to follow ARM and become a licensing juggernaut?
I think on the basis of where we are today, on the basis of the discussion we've had with some of the sort of investors and stakeholders, it has become quite clear in terms of where we're heading. We are going to become potentially one of the suppliers within the UK jurisdiction. And so we'll be supplying cathode materials specifically for lithium, manganese, iron phosphates. But in terms of the global opportunities, we are mostly looking into potentials of licensing as well as joint venture opportunities. We are currently in some of those discussions on the basis of different jurisdictions. And so I think that is predominantly the more sort of an ideal approach for us going forward.
Licensing's a great business. So when you license your technology, you have to, before that, you have to test it and various different applications and use cases. How are you doing that testing?
So as I mentioned, we are currently at a 20 ton per annum pilot line facility scale. Over the past 5 years, we have scaled up the technology from a few grams all the way up to 20 ton per annum. And so we are now able to demonstrate our technology and material samples at such scale. And we have been doing so by supplying samples within a range of a few hundred grams all the way up to kilograms where are needed for the early stage. And then that'll be followed on by further and larger samples normally. And so we have received 6 organizations validation at the cell level. They have manufactured pouch cells to be able to demonstrate our capabilities, which is ultimately one of the sort of a commercial scale battery cells that is normally being used to be able to demonstrate the capabilities of new technologies. And that's how we know that we have developed an LMFP with 80% manganese that can demonstrate 20% uplift in the performance, but it's also a drop-in replacement that's been proven by such organizations.
So a lot of listeners will think, oh, it's all about vehicles and heavy equipment. Will some of your chemistry go into battery storage? I ask that because the density increase, you can potentially get more usage when you're running off the battery. Do you also see your chemistry going into battery storage as well as vehicles?
Yeah, so I would say that it's always been our primary application to work on the EV supply chain. However, we are seeing a growing interest coming through from different areas. Obviously, BESS is one of those, but more importantly, also from Marines as well as defense sector, where they are quite keen to find a safer replacement for their NMCs, but they don't really like the idea of using LFP because of its limited energy density. And so that's where LMFP comes in. So LMFP leverages from majority of the advantages of LFP, except its very high cycle life. But then it does offer a very comparable cycle life compared to NMC, and hence why it is being seen as a much better option compared to NMCs that are being used. And so we are focusing on some of those areas already. We are formalizing some of the MOUs and partnerships already with some of the notable partners within that sector, especially in Europe. And so we're hoping to tap into that market very, very soon.
I would summarize this way, but you're building a business, you're building a growing business that you're hoping to scale and become hopefully as big as ARM. That's what we all want if you're in technology in the UK. In your opinion, sir, what is the future of electric vehicle batteries?
I would say the future of electric batteries, if I was to sort of describe it in a technical terms, the way we will see it is for chemistries such as LFP and LMFP to be adopted, where it can comfortably take care of the range anxiety concerns going forward, and without us having to be too much concerned of its cost competitiveness, because it will be very much affordable within an affordable range, so that it is something that could be widely adopted by the majority, if not all of the end users. And so for once for all, we can comfortably then focus on achieving our net zero goals and be able to claim a role into that from sort of many various sort of point of views, but also as an end user, also to be able to really play a role into that sort of EV transition role, which I think it's very, very important.
When you have good policy enables entrepreneurs such as yourself to build businesses that have a meaningful, positive impact on society. As we look to wrap up this insightful conversation for today, what would you like our listeners to take away with them?
I think we have mentioned this quite a lot already, but I think the EV transition, it is not really an option anymore. It is just a matter of time. And so with regards to the growing public awareness, I think it has become quite clear that it is in favor of everyone to be able to adopt EVs for a better future. That is something that has been also statistically proven at this stage. And so I think it is a matter of also partnership and understanding that the partnership and collaborations are also needed for this matter. And so I'm hoping that Europe, as well as North America and the UK, more importantly, are going to be able to compete in that market and is no longer going to be just driven by Chinese players in that landscape.
It's not a one-size-fits-all market. It's a partnership market. If you don't own an EV and you can afford one, buy one. They're a ton of fun to drive. And not to mention, they're super convenient, but they're fun to drive. Today is tomorrow. Tomorrow is today. The future is Integral's power. Behnam, thank you so much for coming on SAE Tomorrow Today.
Appreciate it. Thanks for having me.
Thank you for listening to SAE Tomorrow Today. Be sure to join us next week as we discuss how the automotive industry is accelerating innovation, balancing costs with consumer demand, and overcoming legacy barriers.
SAE International makes no representations as to the accuracy of the information presented in this podcast. The information and opinions are for general information only. SAE International does not endorse, approve, recommend, or certify any information, product, process, service, or organization presented or mentioned in this podcast.